Okay, so today in class we found the multiplicative inverse matrix. So if you have matrix A, which is a 2 by 2, A, B, C, D, and you want to find the inverse of matrix A, what you have to do is you have to find the reciprocal function, and multiply it to a modified matrix. Okay, so this is going to be our pattern. Now this right here, AD minus CB, is called the determinant. Okay, so you take it and put it under 1, and once you do that, you use this as a scalar and multiply it to your matrix, every single entry. Now to get the modified matrix over here, what you'll do is you'll take A and D, which is your main diagonal, and you'll let them switch places. Your B and your C, which is your other diagonal, you will leave them where they are, but you will negate them. Anytime you negate a number, you change its sign. Okay, so if we look at matrix A, and we let matrix A be 2, 4, 6, and 8. Okay, and we want to find the inverse of matrix A. This little -1 as an exponent means the inverse of the matrix. So what we'll do is we'll do 1 over AD minus CB. So multiply the first diagonal, 2 times 8 is 16, minus, now go to the other diagonal and multiply it. 6 times 4 is 24. So what we end up with is 1 over -8. Now the matrix we're going to multiply it to, we're going to take our first diagonal, which is 2 and 8, and we're going to let those swap places. Our other diagonal, 4 and 6, we're going to negate those or change their sign. And once we have this, we can use -1/8 as a scalar. So we'll multiply -1/8 to 8, and we'll get -1. -1/8 to -4 is going to be +1/2. -1/8 times -6 is going to be +3/4. And -1/8 times 2 is going to be -1/4. So my inverse matrix is -1, 1/2, 3/4, and -1/4. Now, if you take your original matrix A and multiply it to your inverse matrix, you should end up with an identity matrix. So let's see if that's true. Let's take row 1 and multiply it to column 1. So we're going to have 2 times -1, which is -2, and 4 times 3/4, which is 3. Now let's do row 1, column 2. 2 times 1/2 is 1. 4 times -1/4 is -1. Row 2, column 1, 6 times -1 is -6. And 8 times 3/4 is +6. Row 2, column 2, 6 times 2, or 1/2, sorry, is 3. 8 times -1/4 is going to give us -2. Now once I add all of this together, I'll get 1, 0, 0, and 1, which again is an identity matrix. So a matrix times its inverse should always give me an identity matrix. So if I have matrix B, which is 1, -2, 3, and -4, to find the inverse, the first thing that I need to do is I need to put my determinant under 1. So to find the determinant, remember, multiply your main diagonal. 1 times -4 is -4. And subtract it, loop around, and multiply the second diagonal. 3 times -2 is -6. So I end up with 1/2. Now my modified matrix, I'll take my main diagonal, 1 and -4, and I'll simply change their positions. My other diagonal, leave them where they are, but negate. 3 becomes -3, -2 becomes +2. Remember, when you negate something, you change its sign. Now we're going to use 1/2 as a scalar. 1/2 times -4 is -2. 1/2 times 2 is 1. 1/2 times -3 is -3/2. And 1/2 times 1 is 1/2. So the inverse matrix is -2 and 1, -3/2, and 1/2. Now, if we take this next matrix, let's see, 3, 6, 2, and 4, we'll call this one matrix C. Okay, so let's find the inverse of matrix C. First, we need to find the determinant. So I'm going to multiply my main diagonal. 3 times 4 is 12. Then loop around and multiply this diagonal. 2 times 6 is 12. The determinant is 0. Anytime you have 0 in the denominator of a fraction, we know that that's an undefined number. Since this is supposed to be our scalar, that means that there is no inverse for matrix C. Okay, and tomorrow we'll use inverse matrices to solve matrix equations.